Come on, my dears, let us proceed further. Kindly read this statement of numerical number 5 in the exercise. Come on, read it. Look now. We are given a slope of angle theta, height h and length small d. Come on, theta is angle of slope, h is height of slope, d is length of the slope. In this right angle triangle, just find out sin theta. It will be common opposite upon hypotenuse. Opposite is h, hypotenuse is d. So it is h upon d. Fine. We are given one thin hollow cylinder which rolls down the slope without slipping, for which we are asked to find out acceleration parallel to the surface of the slope. Let us find out. By the time that cylinder comes from top to bottom, correct? You know what is going to happen? There will be decrement in gravitational potential energy and there will be increment in kinetic energy, correct? Decrease in potential energy equals to increase in kinetic energy. Come on, decrease in potential energy is by amount mgh, increase in linear kinetic energy is half mv square, increase in rotational kinetic energy is half I omega square. Fine. mgh as it is, half mv square as it is, 1 by 2 as it is. What about capital I? Moment of inertia for extremely thin hollow cylinder, I equals to mr square into omega square. Fine. Now mgh as it is, half mv square as it is, 1 by 2 as it is, m as it is. Don't you know v equals to r omega? So v square equals to r square omega square. Just pick reverse, r square omega square equals to v square. So here it is, r square omega square is v square. Now mv square, if you take common, inside the bracket 1 by 2 plus 1 by 2, that is 1. So it is mv square. Now m and m getting cancelled, giving you v square equals to gh. v square equals to gh, give it equation number 1. Recall third equation of linear motion with constant linear acceleration. V square minus v0 square equals to 2ad. Come on. Because this body started from rest, initial velocity is 0. Initial velocity is 0, put it here. This part is 0. V square as it is. 2a as it is. What about d? Come on, find out d from here. It will be h upon sin theta. d equals to h upon sin theta. Give it equation number 2. Now compare equations 1 and 2. Left hand sides are same, right hand side must be same. So 2ah upon sin theta should be equal to gh. 2ah upon sin theta should be equal to gh. H will be getting cancelled. Find out a. 2 will come down, so it is 1 by 2. G is there and sin theta will go up. So 1 by 2 g sin theta. But what is 1 by 2? It is 0.5 into g into sin theta, correct? This is the acceleration obtained by this cylinder rolling without slipping. Okay, acceleration obtained by the cylinder parallel to the surface of the slope. Suppose they ask in the examination decrease in acceleration due to friction. Then you should subtract this acceleration from g sin theta. You should subtract this acceleration from g sin theta if at all they ask decrease in acceleration due to friction, correct? Right now they have not asked decrease in acceleration due to friction, they have asked acceleration obtained by the cylinder, come on, when it is rolling down the slope without slipping. Acceleration obtained by the cylinder is this much, 0.5 g sin theta. Got it? Fine. Now read number 6. Come on, read it. Let us do one thing here. We are going to derive one very important result because we are going to use it here in this sum. In the examination, you are not supposed to prove that result. You can make use of it directly. What is that result? I am showing you. Suppose this one is x-axis, this one is y-axis, and this one is z-axis. Here is origin, correct? Come on. We have one particle in the three-dimensional space over here whose perpendicular distance from z-axis is suppose r, correct? Just draw one perpendicular on xy plane, that foot of perpendicular is this. Now from here draw perpendicular on x-axis, so this much will give you x coordinate. Draw perpendicular from here on y-axis, this much would give you y coordinate, correct? So this much is x coordinate, this much is y coordinate, fine. And now this, instead of showing x coordinate over here, I just show it over here. So this is also x coordinate, these two are equal. Now these two are perpendicular. So opposite to right angle will be hypotenuse. According to Pythagoras theorem, measurement of hypotenuse will be square root of summation of squares of mutually perpendicular sides. So this much distance would be under root of x square plus y square, under root of x square plus y square. And whatever is this distance, same is this distance, correct? These two are equal. So if this is r, this also will be r, and that r we have proved under root of x square plus y square. Now take square of it, so it will be r square equals to x square plus y square. R square equals to x square plus y square. What is this r? What is this r? Come on, what is this much distance r? It is perpendicular distance of this particle from z axis. So if it is square of perpendicular distance from z axis, then it is x square plus y square. Okay? In general, you just remember, in general, r square equals to x square plus y square plus z square. If they talk about moment of inertia about z axis, then take z coordinate 0. Then you will get r square equals to x square plus y square. Okay? Suppose they ask you to find out moment of inertia about x axis, then you should take x equal to 0. Then when you take r square equals to x square plus y square plus z square, if you take x equal to 0, it will be r square equals to y square plus z square. Similarly, if they ask moment of inertia about y axis, then you can write r square equals to x square plus z square. Got it? Right now about z axis, so r square equals to x square plus y square. Okay? Now for first particle, instead of r, just write r1. Instead of x, you write x1. Instead of y, you write y1. Coordinates of first particle they have given 2, 4, 6 meter. So this is x coordinate of first particle x1, this one is y coordinate of first particle, that is y1. So right now x1 is 2 and y1 is 4. x1 is 2, y1 is 4. Come on, 2 square is 4, 4 square is 16, 16 plus 4 that is 20 meter square. Now tell me, for second particle, instead of r1 square, I should write r2 square, and here it will be x2 square plus y2 square. These are the coordinates of second particle, in which you can see this must be x coordinate, this must be y coordinate. So this is x2 and this is y2. x2 is 3 meter, y2 is 5 meter. Come on, simplify. 3 square is 9, 5 square is 25, 25 plus 9 is 34, distance square, so meter square. Correct? And now what is moment of inertia? By formula, I equals to m1 r1 square plus m2 r2 square. That's all. Because right now system has only 2 particles. So stop at the second term. Okay? Now m1 is the mass of first particle. They have given 100 kilogram. r1 square is ready with us. r1 square is 20 meter square. m2 is mass of second particle, which is 200 kilogram. r2 square from here. r2 square will be 34 meter square. And now simplify. 20 into 100, that is 2000. 34 into 200, that is 6,800. 6,800 plus 2000, it is altogether 8,800. And SI unit of moment of inertia is kilogram into meter square. Because right now mass is given to us in kilogram and all the coordinates are in meter, that's why. Okay. Had they been in gram and centimeter, then we would have written here gram into centimeter square. For MKS unit, it is kilogram into meter square. For CGS unit, you can write gram into centimeter square. Okay, fine. Now read statement of number 7. Read it. According to law of conservation of mechanical energy, loss in gravitational potential energy should be equal to increase in kinetic energy. Come on, loss in gravitational potential is by amount mgh, increase in linear kinetic energy by amount half mv square, increase in rotational kinetic energy by amount half I omega square. 1 by 2 as it is. What about moment of inertia? What are you given in the statement? Which body? Solid sphere. For a solid sphere, moment of inertia about an axis passing through its diameter is I equals to 2 by 5 mr square into omega square. Fine. Now this half mv square as it is, 2 will cancel. This is 1 by 5 m. Don't you know v equals to r omega? So v square equals to r square omega square. Speak reverse. R square omega square can be replaced by v square. Now mv square I can take common. Inside the bracket 1 by 2 plus 1 by 5, it is 7 by 10. 7 by 10. And now tell me, m will cancel, correct? Find out v square, it will be 10 by 7 gh. 10 by 7 gh. Take square root on both the sides, v equals to under root of 10 by 7 into gh. Under root of 10 by 7 into gh. Now this 10 by 7 as it is. What about value of g? You are given in the statement 10 meter per second square. Height of the slope they have given 70 meter. Simplify. Answer is v equals to 31.62 meter per second. Or you may simplify from here. 70 upon 7 that is 10. 10 into 10 into 10 that is 1000. 1000 means 100 into 10. Its square root will be 10 root 10. 10 into root 10. 10 into root 10. That value is exactly this much. 31.62 meter per second. They also asked about rotational kinetic energy. Come on, it is half I omega square. Half I omega square. If it is rotational kinetic energy, you may write Kr. Correct? Rotational kinetic energy Kr. Come on. Rotational kinetic energy is half I omega square. Come on, 1 by 2 as it is. What about moment of inertia? Moment of inertia for a solid sphere. 2 by 5 mr square into omega square. Now 2 will cancel. 1 upon 5 m v square equals to r square omega square. Replace r square omega square by v square. Come on, 1 by 5 as it is. Mass of the sphere you are given 8 kilogram. Velocity value we have found out. Come on, 31.62 meter per second. It's a square. Simplify. Answer is 1600 and that many joule. So this much is the rotational kinetic energy, 1600 joule. Got it? Now read this statement of number 8. Come on, read it. We are asked to find out total angular momentum of whole earth about its axis of rotation. If you take earth as a rigid body, then for a rigid body, what is the formula for finding total angular momentum? L equals to I omega. What is I? Moment of inertia of a solid sphere about an axis passing through its diameter. You know it by formula 2 by 5 mr square into omega. What is formula of omega? 2 pi by capital T. Fine. Now 2 2s are 4 upon 5. Mass of the earth they have given in the statement 6 into 10 raised to 24 kilogram into radius square. Radius of earth 6400 kilometer. Convert it into meter, multiply by 1000 and whole square, multiply by pi. See 2 into 2, you already taken 4 here. So left is now pi. Pi value is 3.14 and divided by capital D. What is it? Periodic time of Earth about its own axis. Come on, periodic time of rotation. Come on, for Earth, you know about its axis is 1 day. But 1 day is how many hours? 24 hours. 1 hour is 3600 second. So you should multiply by 3600. Day to hours, hour to second. And now simplify, final value is 7.15 into 10 raised to 33. This many joule into second. For linear momentum, unit is Newton into second. For angular momentum, unit is joule into second. Got it? Fine. Now read the statement of number 9. Come on, read it. We are given a rigid body. The shape is not specified, so you can take any shape. Here I have taken irregular shape. Okay, come on. This is a given rigid body. Suppose here it is center of mass. So this is an axis passing through center of mass, about which moment of inertia of this rigid body I am taking by symbol IC. Now consider this axis of rotation, which is at distance, come on, 3 meter from this axis, and about this axis moment of inertia of this body I am taking as I1. Take another axis which is at distance 5 meter from this axis, correct? And about this axis, come on, moment of inertia I am taking as I2. We have to find out this I2 value. Okay, perpendicular distance between these two parallel axes, it is 3 meter. Perpendicular distance between these two parallel axes, it is 5 meter. Okay, now don't you know parallel axis theorem? What was the mathematical form? I equals to IC plus MD square. I equals to IC plus MD square. Come on, for a given rigid body, moment of inertia about an axis passing through center of mass is constant. IC is constant. For a given rigid body, mass is also constant. So when in the first case, when you write here D1, here you should write I1. In the second case, when you write here D2, here you should write I2. And now I just take I2 minus I1, this minus this, I2 minus I1, IC minus IC will cancel, this minus this, M I can take common, inside the bracket D2 square minus D1 square, D2 square minus D1 square. And now minus I1, if I transfer on this side, will become plus I1 in plus M into D2 square minus D1 square. What is this moment of inertia? About first axis, they have given in the statement, come on, 8200 kilogram into meter square. Total mass of the body, they have given 200 kilogram. Come on, D2 is 5 meter and D1 is 3 meter. D2 is 5 meter, D1 is 3 meter. Simplify. 5 square is 25, 3 square is 9, 25 minus 9, that is 16. 16 into 200, that is 3200 plus 8200, altogether it is 11,400. SI unit of moment of inertia is kilogram into meter square. Okay. Read number 10 now. Read it. What is given to us? A square having length of the side as small a, having equal point masses, each of them equal to small m, located at 4 vertices. And what does this system do now? It rotates about an axis passing through its center perpendicular to its plane, and then we are asked to find out total moment of inertia. Come on. For each of this particle, you can see perpendicular distance from the center O, it is same, correct? And that equal distance, if I take a small r, how much it is? Let me find out. This side length is A, this side length is also A, because it is a square, all the sides will be of same measurement. And what about now hypotenuse? Come on, measurement of hypotenuse, square root of summation of squares of two mutually perpendicular sides. So under root of, come on, a square plus a square. So it is under root of 2a square, square root will be root 2 into a, correct? So from here to here, it is root 2 into a, and if you want to find out half of that will be from here to here, correct? It will be half of this. So if you divide this value by 2, then it will be a by root 2, a by root 2. Equal distance of each point mass is a by root 2 from axis of rotation. So whether it is r1 or r2 or r3 or r4, all the four distances are equal, each of them being equal to a by root 2, a by root 2. And all the point masses are also equal, let it be small m. For a system of 4 particles, how would you write moment of inertia? Moment of inertia is m1 r1 square plus m2 r2 square plus m3 r3 square plus m4 r4 square, because our system is right now made up of 4 particles. Come on, m1 is m, r1 square, make square of this. Square of this will be, r1 square will be, come on, a square by 2, correct? So r1 square is a square by 2. Come on, m2 is m, r2 square is also a square by 2. m3 is m, r3 square is also a square by 2. m4 is m, r4 square is also a square by 2. So m into a square by 2, such term is getting repeated in addition 4 times. So m into a square upon 2, that should be multiplied by 4. Come on, 2 2s are 4, so it is 2m square, 2m square, got it? So right now this is the moment of inertia of a given system about given axis of rotation, okay, fine. Read number 11 now. A square by 2. So m into a square by 2, such term is getting repeated in addition 4 times. So m into a square upon 2, that should be multiplied by 4. Come on, 2 2s are 4, so it is 2m square, 2m square, got it? So right now this is the moment of inertia of a given system about given axis of rotation, okay, fine. Read number 11 now. Read it. Now we are given a square having side length as small a. At each of the 4 vertices, there lies a solid sphere of mass capital M and radius capital R. And now this whole system is rotated about this axis of rotation, which is passing through any one of its 4 sides. When it does so, what is the total moment of inertia of entire system? Let us find out. Look, when this system is rotating about this axis, for this sphere, you can say axis of rotation is passing through its diameter, and then moment of inertia should be given by this formula, 2 by 5 mr square, correct? For this sphere also, when it rotates about this axis, which is passing through its diameter, then moment of inertia should be 2 by 5 mr square, correct? Let this be shown by symbol IE, because it is for that sphere which is located at point E. Let this be shown by symbol IF, because it is for that sphere which is located at point F. That's why. But so far, these and this sphere are concerned, correct? For them, axis of rotation is not this. Axis of rotation is this, okay? Now tell me, for this sphere, say sphere located at point G, if moment of inertia is IG, then according to parallel axis theorem, Ig equals to Ic plus md square, where Ic is the moment of inertia of this sphere about an axis passing through its diameter, and m is its mass, d is the perpendicular distance between these and these axes which are parallel. Come on, Ic, Moment of inertia of this sphere about this axis passing through its diameter would be, you know by formula, 2 by 5 mr square plus m as it is. What is this d? Perpendicular distance between these axes and this axis. That perpendicular distance is a. So instead of d I am writing a, it's a square. Now similarly IH also equals to IC plus MD square according to parallel axis theorem. Come on, what is IC? Moment of inertia of this sphere about this axis passing through its diameter, which is 2 by 5 mr square plus m as it is. What is this d? Perpendicular distance between these two parallel lines, and it is a. So it is a square. Now tell me, because we are interested in finding out moment of inertia of entire system, we should make addition of all these component moments of inertia. Come on, you should take addition IE plus IF plus IG plus IH. IE plus IF plus IG plus IH, let it be I. Now, when you make addition this way, this plus this plus this plus this, that is this plus this plus this plus this, tell me 2 by 5 mr square, it is coming 1, 2, 3, 4 times. So, this 2 by 5 mr square I just multiply by 4 because it is in addition coming 4 times. And this ms square it is coming 2 times. So, this ms square is multiplied by 2, correct? Now tell me, if I take 2 and 2 common, 2 and 2 if I take common, inside the bracket left from here it is 4 by 5 mr square, 4 by 5 mr square. Come on, 2 has gone out, left inside the bracket from here it will be ma square. So, this gives you moment of inertia of this given system about this given axis of rotation. Got it? Kindly read this statement of number 12 now. Come on, read it. Look, we are given a linear system in which there are 4 particles, correct? They have masses respectively 1 kilogram, 2 kilogram, 3 kilogram and 4 kilogram. And then if the system rotates about an axis passing through this particle and perpendicular to this length, then what is the moment of inertia? We are asked to find out that. For a system of 4 particles, I equals to m1 r1 square plus m2 r2 square plus m3 r3 square plus m4 r4 square. What is first mass? 1 kilogram. What is the perpendicular distance of first particle from axis of rotation? It would be 0 because that particle itself is lying on this axis of rotation. So, r1 is 0, m2 is second mass is 2 kilogram. For this particle, perpendicular distance from this axis of rotation is 2 meter, it's a square. M3 is 3 kilogram and its perpendicular distance from this axis of rotation would be 2 plus 2, that is 4 meter, it's a square. M4 is 4 kilogram. Its perpendicular distance from this axis of rotation will be 2 plus 2 plus 2, that is 6 meter and 6 meter square. And now tell me, this is 0 square is 0 into 1 is 0, 2 square is 4, 4 2s are 8, 4 square is 16, 3s are 48, 6 square is 36, 4s are 144. 144 plus 8, so it is 152 plus 48 will be 200. SI unit of moment of inertia is kilogram into meter square. Okay, so this gives you moment of inertia of this given system about this given axis of rotation. Read number 13 now. Come on. For a body rolling without slipping, what is total kinetic energy? It is translational kinetic energy plus rotational kinetic energy. Come on, translational or linear kinetic energy is by formula half mv square. Rotational kinetic energy by formula it is half I omega square. Now half mv square as it is, 1 by 2 as it is. Moment of inertia for a solid cylinder or for a solid circular disc, don't you know, it is half mr square into omega square. Half mv square as it is, 2 2s are 4, so it is 1 by 4 m. You know v equals to r omega, so v square will be r square omega square. Speak reverse, r square omega square will be v square. R square omega square will be v square. And now this is mv square if I take common, inside the bracket 1 by 2 plus 1 by 4, that is 3 by 4. Just give it equation number 1. What about rotational kinetic energy? Rotational kinetic energy by formula half I omega square. Half I omega square. Now tell me, 1 by 2 as it is, you are talking about solid cylinder for which I equals to half mr square into omega square. And now 2 2s are 4, m as it is, don't you know, r square omega square is nothing but v square. R square omega square is nothing but v square. And now they have asked a ratio of rotational kinetic energy to total kinetic energy. Rotational kinetic energy has come out to be 1 by 4 mv square here. And what about total kinetic energy? 3 by 4 mv square. 3 by 4 mv square. mv square getting cancelled from numerator and denominator. 4 also getting cancelled. Left is 1 by 3. 1 by 3. So this gives you ratio of rotational kinetic energy to the total kinetic energy. Got it? Kindly read the statement of number 14. Tell me, what is given to us? An extremely thin circular ring having mass capital M, radius capital R. When it rotates about an axis passing through its center and perpendicular to its plane, about that axis, what is its moment of inertia? We have to find out. Look, first of all, do one thing. This total mass of the ring, just consider it to be divided into extremely small mass elements. One such a specimen mass element I have shown here. Come on. For this mass element, mass is suppose dm, and suppose corresponding length in which that mass is contained is suppose dx. Then you know mass per unit length is nothing but linear density of mass shown by symbol lambda. Now for the entire ring, if total mass is capital M, then I should write here total length of the circumference. For a circle of radius r, what is the circumference? 2 pi r. Mass upon length, this is for entire ring. This is also mass upon length, but this is for only one mass element. Linear density is same everywhere. Come on. Now for one small, extremely small mass element, you may take it as one particle, and whenever any particle is rotating about some axis, keeping itself at perpendicular distance r, then what is the moment of inertia? It is mass into square of perpendicular distance. Mass into square of perpendicular distance. Mass is dm, square of perpendicular distance is r. Okay, come on. Mass into square of perpendicular distance. Now di as it is, see this is not the total moment of inertia, this is part of the total ring, and that's why, because this mass is the mass of the, fractional mass. This is the mass which is partial mass, and that's why this is the moment of inertia which is called partial moment of inertia. We just show it by symbol di. Come on, what is dm value? Dm value from here, it will be m into dx upon 2 pi r. Come on, dm will be, come on, m upon 2 pi r into dx. M upon 2 pi r into dx into r square. Now tell me, 1 r will be getting cancelled, correct? So what is left? mr upon 2 pi. mr upon 2 pi into dx. Just take integration on both the sides. Integration di, and here mr upon 2 pi is constant taken out. Closed integration dx. Closed integration dx. Why you are taking closed integration, which is normally shown by this symbol? You have to put one empty circle over the symbol of integration, which is called closed integration. Why? Because as you have selected one mass element over here, second mass element is this, third, fourth, fifth, sixth, seventh, dash, 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 and so on. Okay. So I mean to say, you are going to shift this mass element along the periphery, along the circumference of the ring, and when you do that, your journey is on a closed path. Your journey is on a closed path. That's why we take here closed integration. Okay. Now summation of partial values of moments of inertia will give you total moment of inertia. Let it be capital I. This mr upon 2 pi as it is. Correct? This part as it is. What is closed integration of dx? Closed integration of dx means summation of lengths of all the length elements chosen over the circumference of a ring, and that would give you total length of the circumference, and total length of the circumference of a circle with radius r is how much? 2 pi r. So this much value is equal to 2 pi r. 2 will cancel, pi will cancel, so m is as it is, r into r, that is r square. I equals to mr square. I equals to mr square. This gives you moment of inertia of a ring having mass capital M, come on, having radius capital R, when it rotates about an axis passing through its center perpendicular to its plane. And as such also you know this formula, but how it can be derived, that I have shown here. I equals to mr square. Okay. Kindly read this statement of number 15. Come on, read it. Look, we have one horizontal wire, correct? It is extremely thin, very light in weight, almost massless. And though there are 5 forces exerted on it, it so happens that it remains horizontal. It remains horizontal. And when it remains horizontal, then you must say whatever is the moment of resultant force, same should be equal to algebraic summation of moments of component forces. Same should be equal to algebraic summation of moments of component forces. So let us follow accordingly. Here they have not given that which force is greater, but because 3 forces are exerted vertically upwards, we will take upward force greater than smaller force. 3 forces F1, F2 and F4 are exerted vertically upwards. 2 forces are exerted vertically downwards, F3 and F5. So in upper direction, number of forces is more. So we take greater force in upper direction and smaller force in downward direction. So what is resultant force now? Whenever forces are exerted in mutually opposite directions, at that time, for finding out resultant force, what you should do? Greater force minus smaller force. Greater force is upward force, which is the total of all these 3, F1, F2 and F4. F1 plus F2 plus F4, this is total upward force minus total downward force. Come on, it is F3 plus F5. Bigger force minus smaller force will naturally give you resultant force. But because bigger force is in upper direction, this resultant force will be also in vertically upper direction. Okay, fine. Now, out of these 5 forces, suppose resultant force is F, and suppose it is exerted this way, correct, in vertically upward direction. So this becomes now line of action of that force, and perpendicular distance of line of action of force from this reference point A is suppose X. Okay, fine. Now what I have written here, for this wire to remain horizontal, what should happen? Moment of resultant force should be, come on, algebraic addition of moments of given forces. Algebraic addition of moments of given forces. What do you mean by moment of force? Moment of force is nothing but torque, and it is force into perpendicular distance. Force into perpendicular distance. What is the resultant force? Resultant force is F, and perpendicular distance of line of action of resultant force from this reference point is X. That's why written here F into X. If any force is vertically upward, we will take its moment as positive. If any force is vertically downward, we will take its moment to be negative. Come on. Where is F1? Upward. So take it positive plus F1 and into perpendicular distance of line of action of force F1 from this reference point. That perpendicular distance is 0 because this point itself is lying on the line of action of force F1. Point itself is lying on the line of action, then perpendicular distance will be 0. Come on, F2 is upwards, so I should take it positive and multiply by perpendicular distance of line of this force, line of action of this force from this reference point, which is x1. So F2 into x1. Similarly, come on, F3 is downward, so I should take it negative minus F3 into perpendicular distance of line of action of F3 from this reference point. It will be x1 plus x2. Come on, x1 plus x2. Come on, F4. F4 is vertically upwards. F4 is vertically upwards, so I should take it positive plus F4 into perpendicular distance of line of action of this force from this reference point. It will be x1 plus x2 plus x3. x1 plus x2 plus x3. And what about F5? It is vertically downwards, so I should take it negative and F5 into perpendicular distance of line of action of this force from this reference point. It will be x1 plus x2 plus x3 plus x4. x1 plus x2 plus x3 plus x4. Correct? And now I want only x, so I should make it subject of the equation. I should transfer this f in the denominator. So come on, make subject of the equation as x. This numerator part I have written as it is. Look and just check it. Verify. F1 into 0 is 0. F2 into x1. Here it is. F2 into x1. Minus F3 into x1 plus x2. Minus F3 into x1 plus x2. Plus F4 into x1 plus x2 plus x3. Plus F4 into x1 plus x2 plus x3. Minus F5 into x1 plus x2 plus x3 plus x4. Minus F5 into x1 plus x2 plus x3 plus x4. And divided by capital F. Divided by capital F. What is capital F? Come on. Resultant force magnitude is how much? F1 plus F2 minus F3 plus F4 minus F5. Here it is F1 plus F2 minus F3 plus F4 minus F5. I repeat, what is F? F1 plus F2 minus F3 plus F4 minus plus minus F5. Here it is minus F5. Got it? So this gives you perpendicular distance of line of action of resultant force from reference point A. Okay.